We are excited to present our final project for CS428, CipherCre8r, which is a desktop-based application that aims to demonstrate various AES and DES-based encryption techniques. Our team has collaborated to develop a tool that provides hands-on learning for real-world encryption standards. Let's meet the team behind CipherCre8r. Hannah has led the implementation of both DES and AES and designed the user interface. Jonathan focused on CBC and handled our project demonstration. Alec worked on implementing CFB, and Jaren developed the CTR mode, and everyone assisted in the presentation design. Together, we've combined our skills to build a comprehensive encryption tool. When implementing this project, everyone had to do their own research on how each method was created and used. When breaking down everyone's tasks, Hannah found that using a Python library, tkinter, was the best way to create an interactive user interface for this project. She also researched how to implement AES and DES encryption and decryption methods using Python. Jonathan focused on the initial organization of the project, including initial project ideas and creating the project proposal document. He was able to implement the CBC encryption and decryption methods using Python and led the research on CBC encryption. Alec was in charge of organizing the PowerPoint and implementing the CFB encryption and decryption modes in Python. He led the research on CFB encryption. Jaren was in control of the main research sections and focused on implementing the CTR methods of encryption and decryption of this project.
Our encryption and decryption application was developed in Python with the goal of having the ability to encrypt messages in the DES, AES, CBC, CFB, and CTR encryption methods. A user of our application can select whichever encryption method they want to use, as well as the message they would like to encrypt, and our application will return the encrypted ciphertext. Our application will then output the decrypted plaintext message using the same encryption and decryption algorithm. The AES encryption method has many uses and is primarily used for encrypting things like bank transactions, medical records, and personal messages. The DES encryption method is also used for encrypting types of data, but is more commonly used for things like virtual private networks and random number generation. The AES, or Advanced Encryption Standard, was primarily developed to replace the DES, or Data Encryption Standard, due to the DES's susceptibility to malicious brute force attacks. As a result, AES is much more resistant to brute force attacks than DES. AES was the winner of an open cryptography programming competition organized by NIST in the 1990s. Formerly known as the Rijndael algorithm, AES was created by Derman and Rijman and was selected as the winner of the competition in 2000 and was later standardized as the AES algorithm in 2001.
We set out with two primary goals for our project. First, we wanted to develop an interactive application where users can select an encryption method and input their plaintext. This allows users to experience the encryption process in a practical, hands-on way. Our second goal was to accurately implement these encryption algorithms in Python, enabling both encryption and decryption. This ensures that the users can fully appreciate the security cycle from end to end. Our project timeline started off on April 3rd. Initially, we concentrated on the design and encryption research to lay out a strong foundation. Then we moved on to the hands-on phase, where we implemented and tested our encryption algorithms to ensure they were secure and effective. Finally, we developed a friendly user GUI and carry out final testing to ensure everything functioned seamlessly. Each phase was crucial for building a reliable application. Our development process spanned 4 weeks and was organized into 5 key milestones. In the first week, which contained 2 milestones, we focused on our project proposal and the initial prototype. Week 2 was dedicated to the developing of the GUI and beginning application testing. Week 3 centered on implementing the encryption algorithms. And the final week was for perfecting our presentation and completing the last rounds of app testing.
During the previous demonstration, it was shown that the user first must select the encryption mode that they would like to have in a list box. Once their selection has been chosen, the user must confirm their choice with the Select Mode button. From there, the mode selected will be displayed in the top right corner of the program. After that, the user is able to enter a string of text that they want to have encrypted. The user shall then click the Encrypt button, and the encrypted results will appear in hexadecimal format. To confirm that the message was encrypted properly, the program then decrypts the message and prints out the result of the program. The user is able to enter as many new strings as they would like to be encrypted using a chosen mode. If the user decides to encrypt the same message multiple times, each ciphertext will be different, as the key implemented for all modes is randomly generated. To change modes, all the user has to do is click another mode from the list box and confirm the change with the Select Mode button. As previously explained, the current mode box will display the mode selected.
In conclusion, CipherCre8r stands as a testament to practical application of advanced encryption standards in accessible format. We've achieved a significant milestone in making encryption understandable and usable for everyone. We are excited about the future enhancements and broader adoption. Thank you for your attention. We are now ready to take on questions you might have. For our project, we utilize a variety of resources to ensure accuracy and reliability. These included review of AES publication, which provided guidance on the use of AES encryption algorithm. This publication from the National Institute of Standards and Technology helped us understand AES encryption standards thoroughly. We also used GitHub, which offered collaborative tools facilitating seamless development and version control for our project. PyCryptoDome was a source we used as a Python library that provided cryptographic tools and algorithms, including AES and DES, ensuring a robust implementation of encryption method in our application. Our last source was Business Tech Weekly. This online resource provided insight into data encryption standards, offered valuable context on its history, its application, and the significance in the cybersecurity landscape. With these resources, they were instrumental in our project's success, providing valuable information, tools, and perspective to build CipherCre8r.